Okay, class, welcome to day 9 of calculus, more particle motion. We are going to pick up where we left off on day 8, looking how particles that maybe move just horizontally left and right. So, our key. So, when we talked about particle motion last class, I was giving you a equation for the position of the particle. Now, let's talk about two different things, displacement versus distance. Displacement is the change in your position. It could be positive or it could be negative. It's basically the delta S of t, which is when you subtract your position at two different times. As opposed to distance, which is the absolute value of your displacement. Distance can only be positive. Easiest way to think the difference between the two. You run one lap around a track. And you start here, and you go here. Start and stop. Well, your displacement after running one lap is equal to 0 because you haven't changed positions. You're exactly where you were when you started. But your distance that you ran was equal to one lap, or let's say 400 meters. So when we do this, we have to incorporate how distance is calculated because it's always positive, no matter if you're moving left or right. Your displacement may be positive or negative, but your distance will always be positive. Going with this idea of distance is this idea of speed. Speed again can only be positive. Your velocity can be positive or negative depending if you're going left or if you're going right, if you're going up or you're going down. Velocity is a vector that has direction. Speed does not. It is only magnitude. So it is the absolute value of speed. So let's look at this table. Let's see how we can look at how is something speeding up or slowing down. Oh, wow. Perfect. So let's look through some examples. Let's say I have a velocity that is equal to 3, and my acceleration is equal to 2. That means this is positive, and this is also positive, which means my velocity is getting more positive, which means I'm speeding up. My velocity is positive, and it's getting more positive. I'm speeding up. Let's look at this example. My velocity, again, is going to be positive, but my acceleration now is going to be negative. So when we talk about this, again, my velocity is positive, but my acceleration is negative. That means my v is getting less positive. That means I'm slowing down. Yes, I have a positive velocity, but it's getting less and less positive all the time. I'm hitting the brakes. You hit the brakes on your car, you're still going forward, but your speed is slowing down. It's less and less positive. Okay, let's look at this. My velocity is equal to negative 3. My a is equal to 2. Well, my velocity here is negative now. My acceleration is positive, which means my velocity is getting less negative. If a velocity that has a negative value and your acceleration is positive, that means those velocity values are getting less and less negative, that means I'm also slowing down. And then finally, my b is equal to -3, my a is equal to -2, and my velocity is negative, my acceleration is also negative, means my velocity is getting more negative. That means I am speeding up. A negative velocity getting more and more negative means it's going faster than it was before. So if you see all this, you can see that these two tended to be the same, and these two were the same. And that's because I'm speeding up when V and A have the same sign. Both are either positive or negative, as opposed to when we're things slowing down, when B and A had opposite signs. That means one is positive and the other is negative. And that's kind of the summary of how we can tell things is going faster or slower. Okay, we're going to go through an example, figure out displacement, distance, and so on and so forth. It's very similar to the example that we did last class. S of t equals 4t squared minus 48t plus 3, except now the interval of time is t is greater than or equal to 0, not the 0 to 10 that we did last class. So our displacement, or delta s, is the position at 5 seconds minus position at 0. I did my calculations. So my displacement is -137 minus 3. So my total displacement is equal to -140 feet, which means I went left. For part B, I have to figure out the displacement after 10 seconds, and now I'm going to do delta S is equal to -77 minus 3, and I get my displacement now is -80 feet. That means I went left from the beginning of time. So what does it mean when the particle is stopped? The particle is stopped when the velocity is equal to 0. So I need to take my equation here. Sorry about that glitch. So I'm going to take my position equation and take its derivative, and then my velocity equation is going to be 8t minus 48. I'm going to set it equal to 0. And I get t equals 6 seconds. That is when it is stopped. Now I'm going to make a number line using 6 seconds. So I made my number line of my velocity equation. Notice it does not go left forever. It starts at t equals 0, so I started at 0 seconds, put 6 seconds on there when my velocity was 0, my leading term, and I have negative and positive velocities. So this is where it moves left, this moves right. So my left is from 0 through 6, and my right is from 6 to infinity. So now I have to find the distance. It is not displacement. I have to break it into two parts using this idea that at 6 seconds is when the velocity is 0, and from 0 through 6, it is moving left, and from 6 to 10, it is moving right. Either way, the distance is positive, so I had to do each little distance for each little part. Okay, so I broke it down into my two parts. At 0, my position was 3. At 6, my position was negative 141. And at 10 seconds, my S of 10, or my position, was negative 77. Distance is the absolute value of your displacement. So I did the absolute value of delta S from 0 through 6, and the absolute value of the delta S from 10 to 6, and I got the result. So my total distance is, when I add these two together, I get 208 feet is the grand total distance that it traveled, left and right. So now I have to figure out the acceleration equation. So I take the velocity equation. I'm going to take its derivative. So I get a of t is equal to h. It means it's always positive. If I made a number line of this, starting at 0 and going out, it will always be positive, which means velocity is always increasing. That's always going on. The velocity is always getting a higher and higher and higher value. Not the speed, it's velocity. So I brought my velocity and acceleration equations down so we could see them. So is it speeding up or slowing down at t equals 5? Well, at 5 seconds, my v of 5, plug it in here, I get negative 8 feet per second. And my acceleration at 5, it doesn't matter what time it is, it's always going to be 8 feet per second squared. And slowing down, since velocity is equal to a negative and a is equal to a positive, they are opposite of each other. So the velocity is getting less and less negative all the time. Now when I do it at 10 seconds, v at 10 is equal to 32 feet per second. And my acceleration doesn't matter. It's always 8 feet per second squared. And it is speeding up, since both v and a equal positive. Okay, we're working on another example. It's a little bit more difficult. It's a little bit more difficult function. It's a cubic instead of a squared. So my displacement is just changing my position. Delta x is going to be x of 2 minus x of 0, which is negative 16 minus negative 2. And I get a total displacement equal to negative 14 inches, which means I had moved left. The next one I'm going to do is going to be x of 8 minus x of 0, which is 230 minus a negative 2. So now I get my displacement is equal to 232 inches, which means I moved right from 0 to 8 seconds. Now, again, when does the particle stop? The particle stops when the velocity is equal to 0. I take my position equation, I take its derivative, and I find v prime is equal to 3t squared minus at minus 3. I have to factor this. When I factor it, I get 3t plus 1 and t minus 3. I'm going to get two solutions for t. One solution for t is equal to 3 seconds. I kind of like that one. This other solution is t equals negative 1/3, which I can't use. It's not in the domain. My domain for time, which was given earlier, was t is greater than or equal to 0. I can't use negative seconds, so I'm going to make my number line of velocity starting at 0, and I have 3 on here, and my leading term is 3t squared, and when I put in my stuff, my values, the right side is positive, left side is negative, so this is where it goes left, this is where it goes right. It is stopped at 3 seconds, and it goes left from 0 through 3, and it goes right from 3 to infinity. Okay, if I want to know the distance after 10 seconds, I have to break it down from 0 to 3 seconds when it was moving left, and from 3 to 10 seconds when it's moving right. Remember, distance is the absolute value of that displacement. So I use my values for s of 0, s of 3, s of 10, and I figure out the distance from 0 to 3 was 18, and from 3 to 10 seconds was 588, and now I'm going to add them together, and I get a total of 606 inches is equal to the total distance traveled. Okay, so now I want the acceleration equation. I take the velocity equation, I take its derivative. And we go from there. And I set this equal to 0. I get t equals 4/3 seconds. I'm going to use this as a number line. This is my acceleration. Starts at 0, and at 4/3, I have this time right here. And I made a little mistake. I'm going to get rid of that prime. And I'm going to change the color to light blue. My leading term is equal to 6t. That means this is positive and this is negative. So basically what's going on at t equals 4/3, the velocity is at a minimum, because my acceleration goes negative, 0, positive. It means it bottoms out. I'm going to keep this in mind when I do more of this problem. So I brought the velocity and acceleration equations down the page so I can see them, and I'm going to calculate the v and a at 2 seconds, at 10 seconds, and 1 1/3 seconds. Well, at 2 seconds, my velocity is negative 7, my a is 4. At 10 seconds, I have 217 for the velocity, and the acceleration is 52. And at 1 1/3 second, I get negative 8 1/3, and my velocity is 0. So let's figure out what all this means. Are things speeding up, slowing down, or we have no idea what's going on? Well, obviously right here, my velocity is negative, my acceleration is positive. It is slowing down since v and a have opposite signs. Yes, the velocity is negative, but the acceleration being positive means the velocity is getting less and less negative. What's going on here? Well, it is speeding up. Both v and a are positive. What does this mean? Not only the velocity is positive, it's going to get more and more positive because the acceleration is positive. And finally right here, we kind of talked about this. It's doing neither, speeding up or slowing down. At this time, the velocity is at a minimum, so we discussed about 2 minutes ago, since a is equal to 0. It's not speeding up or slowing down. It's hit its minimum. And finally, on what intervals are they is the particle speeding up. That means velocity and acceleration have to have the same sign. So if you look on here, we're solving for time. So on the interval 0 to 4/3, not bracket, with union 3 to infinity, they have the same sign because here they're both negative, and on this interval they are both positive. Again, I have the handwritten notes that you could download if you want to see more calculations, but this pretty much is it. Thank you for watching.